Friends, let's get back into function notation. So notice we've got four different functions. F, G, H is the graph, and K is the table. So when we're doing G of -5, remember -5 is the X value in G. So every place we see an X, we're going to replace it with -5. So negative, and then -5 squared plus 3 times -5 minus 4. Careful to do some order of operations here. This is negative, and then -5 squared is a 25, but there's a negative up front, so it still looks negative. Positive 3 times -5 is a -15 minus 4. And then we add and subtract from left to right. This becomes -44. Part B, H of 2. Again, 2 is an X value. So we follow it across until we get to an X value of 2, follow it up to the graph. The ordered pair 2, 2 is on the graph. So the 2 X value maps to a 2 Y value. K of 3, again, 3 is an X value. So we're looking here at this spot right up here. 3, 0 is the ordered pair. Since 3 is the X value, it maps to a Y value of 0. Next one down, this is our composition of functions, H of G of 0. So we would start with the inside first. So let's find G of 0. So G of 0 is equal to -0 squared plus 3 times 0 minus 4. So those things go away. So G of 0 is just -4. So then we can literally replace G of 0 with -4 and say H of -4 is equal to, and that's where we have to go back over to the graph up here again. So following this up, an X value of -4, we follow it over to -4 up to the graph. It looks like the ordered pair -4 up 4 is on that graph. So H of -4 is really equal to 4 here. So in total, H of G of 0 is equal to 4. Okay, the next composition. So again, we start with the innermost parentheses first. So let's find H of 3. Okay, so starting kind of fresh each time here. H of 3, again, H is the graph. So we're following it over to an X value of 3. Follow it down to the graph. It looks like the ordered pair 3, -1 is on the graph. So H of 3 can be replaced with -1. And then bringing everything else down, now we're looking for F of -1, which means we go over to our function F above. So every place we see an X, we're going to replace it with -1. So 2X minus 1 would be 2 times -1 minus 1. And this looks like -2 minus 1, which is equal to -3. Okay, last one here on this part, 18C. Again, starting with our innermost function. So H of -2. So H of -2 maps, there's an ordered pair -2, 1 on the graph. So H of -2 is 1. And then find K of 1. So again, K takes us back to our table up here. So X value of 1 maps to a Y value of -5. Okay, moving along. I'm going to zoom out so I can keep a look at our functions here. So number 19, this one gets a little bit different because I'm not asking for you to plug in a specific value. I'm looking for you to find F of G of X. So let's find G of X, and let's actually just plug in the whole function G of X for what it is. So -X squared plus 3X, and then -4. So we're really finding F of -X squared plus 3X minus 4. So replacing G of X with the actual function. That means that now we're going to go up to our function F. Every place we see an X, we're going to replace it with our new input, which is this whole strand here. So that would be 2 times -X squared plus 3X minus 4 and minus 4. Right, so this is like 2 times the input minus 4. This wants us to distribute that 2 through, so -2X squared plus 6X minus 8 minus 4, which is equal to -2X squared plus 6X. And then we can combine the -8 and -4 to be a -12 there. Oh, I've got a mistake, everybody. I'm looking at this all wrong. This is a -1 here. I'm so sorry. -1, so that looks better. Now we'll have this -9 in here. So this would be a -9. I was wondering why this looked a little goofy. Okay, sorry about that. So 2 times the input -1, not 4. Okay, let's do, I'm going to switch colors just so that I can keep this one up here. Let's do the other direction. Let's do the g of f of x in red here. So this time we're taking the f of x and putting in the actual function. So g of 2x minus 1. So every place I see an x in g, I'm going to replace it with 2x minus 1. So negative 2x minus 1 squared plus 3 times 2x minus 1 and then minus 4. So this part right up here, before you distribute, you need to FOIL, right? Exponents before multiplication. So let's just leave that negative on the outside. Let's FOIL 2x minus 1 and 2x minus 1. We'll end up having to distribute here. So plus 6x minus 3 minus 4 is still hanging out at the end. So if we FOIL first, just this piece, and then leave that negative, this would be 4x squared on the first terms. Minus 2x is a minus 4x, and then a plus 1. Then we'll distribute the negatives. This is really a negative 4x squared plus 4x minus 1. We still have the plus 6x, and then we can combine these things right here to be a minus 7. And I think if we combine everything together, we end up with a negative 4x squared, 4x and 6x, there's 10x, negative 1 and negative 7, there's negative 8. Okay, let's keep working our way down. So g of x minus f of x, I'm going to zoom out again just so I can see the functions better. We just have to make sure that we go in the order of the function. So negative x squared plus 3x minus 4. So negative x squared plus 3x minus 4. This is our g of x function. And we want to subtract all of our f of x function, which is this 2x minus 1 if I confirm. So by setting it up this way, we can see clearly that we need to distribute that negative through the f of x here into both terms. So negative x squared plus 3x minus 4 minus 2x plus 1, and then combine like terms, negative x squared, a positive 3x minus 2x is positive 1x, negative 4 plus 1 is a negative 3. To find g of negative 3, divide that by f of negative 5. So g of negative 3 means we're going to plug negative 3 in to g every place we see an x. So negative 3 squared plus 3 times negative 3 minus 4. So there's the numerator, divided by the denominator of f of negative 5. So 2 times negative 5 minus 1, right, using two different functions. And then we just have to order of operations and clean this up. So I think you'll find if you do your exponents first, this would still end up being a positive 9 when you square it, but then a negative because of the negative out front. Minus 9 minus 4, all over negative 10 minus 1. So I believe this one looks like negative 22 over negative 11, which should be a positive 2 on this one. Let's find k of 0. So that's going to require us to go back up and take a look at the table up above. So k of 0 maps to a y value of negative 8. So let's go ahead and put that back in down here. K of 0 would be negative 8 as a y value, plus g of 1. Every place we see an x in g, we'll put in a 1. So negative 1 squared plus 3 times 1 minus 4. So this is k of 0 is still just negative 8, and then we're going to add that 2. Let's find out what g of 1 is when we clean this all up. So this becomes 1 squared is 1, with the negative up front is still a negative 1, plus 3 minus 4. kind of lumping this together to figure out what this is, we end up with negative 1 plus 3 is 2, minus 4 is a negative 2, so negative 8 plus a negative 2 is equal to a negative 10. Okay, moving on to 21 and 22. So remember what it means to be an inverse. This is just a really quick little exercise to get us to recall that really these two charts up here are very closely related. The one up here, in order to get the inverse, we're simply just switching the XY ordered pairs. So instead of 0, 1, 2, 3, 4 down the X column, that will be our Y column. And then instead of negative 8, negative 5, negative 2, 0, 3 down the Y column, that will be our X column. 0, 1, 3. Right, so it's just a matter of switching the XY columns from above. In number 22, this is really like, I really want you guys to think back to our inverses, and I'm going to give us a little bit more space to do this one. So I apologize, now our table's not going to line up here. I'm going to give us a little bit more space to do this one. This is really, there's a step 1 from inverses, a step 2, and a step 3 process. So step 1 is to put Y in for f of x. Step 2 is to switch the x and y. And then step 3 is to resolve for the new y. So let's walk through this step by step here. We don't have f of x, we have m of x. So we're going to put in a y, right? It's just fancy, it's just the plain way of saying the function notation. So y equals 3x minus 8 over 5. So step 1 is already done. Switching the x and y, I always draw the arrows. So x is equal to 3y minus 8 over 5. So step 2 is already done. And step 3 is just to resolve for y here. So the first thing we want to do is get that 5 out of the denominator. So we'll multiply both sides by 5. So 5x is equal to 3y minus 8. Let's add 8 to both sides. So we end up with 5x plus 8 is equal to 3y. Moving this up over here for a little bit more room. Our last move here is going to be divide both sides by 3. So 5x plus 8 divided by 3 is equal to y, right? Everything has to be divided by the 3 there. So this is one way of writing this, right? And technically this is your m inverse of x, is 5x plus 8 over 3. So this is one way that we could write this answer, but you could also take note that somebody might look at this and say, oh, if I actually did the division by 3, this could also look like 5 thirds x plus 8 thirds is equal to m inverse of x. That's what that new y is m inverse of x.